I should have realized, even though my microphone had the light on, that's not enough. All right. You can still hear me okay?
Yeah.
Okay, good. Glad that problem is solved. I hate it when I have problems like that. Okay, let's look at this work.
And then 67 is square root of x minus 1.
Hold on.
It got cut off in the picture.
Yeah. Oh, okay, I see. First of all, let's talk about how we're going to do these. In other words, are we going to try to figure out what the cube root of x looks like and look for its transformation? Or are we going to plot points and see which graph matches which? What do you think?
No, I was having trouble with just the transformations.
Okay. Then let's do it that way, and I think that's what they want you to do anyway. Okay, so let me move this up higher here. Let's see. I can't do that, can I? All right, let's see. So we've got two basic functions here. One of them is the square root of x, and the other is the cube root of x. Okay, so let's make sure we know what each of those looks like. Square root of x looks like this. Starting with a closed dot right there. There's no asymptotes on that curve. Okay, that is y equals square root of x. Now, cube root of x is the inverse of this, which is, in other words, I don't know what the cube root looks like other than to know that it's the inverse of that. So let's see, if I try to draw the inverse of that, every point is like this, and these points are like this. Okay? You with me so far?
Yeah.
In other words, I didn't remember what the cube root function looked exactly like. But this makes kind of sense. It should look an awful lot like the square root function to the right of 0. Okay, that is the cube root of x. Okay, so let's take a look at 62. We've got the cube root of x being done. What's the consequences of the plus 2?
Does it move it right to?
No, that's a vertical shift. When the number comes after the function, in other words, what we're looking at in 62 is f of x plus 2. We're not looking at f of x plus 2 like that. We're looking at the first one. This is a vertical shift. This is a horizontal shift. Okay? In other words, the vertical shift would look like this. The horizontal shift would look like this. See the difference?
Yeah.
So if the number is inside the function, it's a horizontal shift. If it's outside the function, it's a vertical shift. So let's figure out which one of these is the function that I drew, this one right here, moved up by 2 units.
I think it would be f.
Yeah, I can't see it, but that's the only one that fits. In other words, f looks like it's been moved up by 2 units. Okay. 63, which one is that?
C.
Okay, 64. The minus 2, which way is that going to go horizontally? To the right or the left?
Right.
Because the standard is x minus h. And when h is positive, you move it to the right. So here, h is a positive 2, which means 2 to the right, which means B. Okay, let's look at 65. Now 65, here's our standard. So what's the consequences of this plus 1?
Move left 1.
Which graph is that?
E.
Good. 66, what's the consequences of the minus sign?
Isn't it the flipping over the x-axis?
Correct. And again, if that minus sign is inside the function, it's a flip over the y-axis. So if it's in front of the function, in other words, if it's, in this case, it's minus f of x. That's what I mean by in front of the function. Inside the function would be this. Okay, so this is a flip over the x-axis. This is a flip over the y-axis. So, what else do we need to know about which do I do first? And does it matter?
Yeah, it does matter.
Sometimes it matters. In this case, doesn't matter. Notice why. In other words, if we flip first, then we're going to move left 1. Well, that's that picture right there at A, right?
Yeah.
Well, if we move left 1 and then flip, we get that same graph. Where it matters is if you have a flip over the x-axis and you're moving it vertically, shifting it. In other words, if this plus 1 was outside the radical sign, then it would make a difference which you did first. To be safe, you always want to do your flips first, both of them. In other words, if you have minus square root of minus x, then you just do both flips. It doesn't matter which one you do first, but the safest thing is you do all flips before you do any of the other 4 things that you can do. In other words, vertically or horizontally shift, or vertically or horizontally stretch, or shrink. All right. 68 next.
I actually don't need to do those. It would just be the next picture.
Okay.
And then just the bottom part of the next picture.
73?
Yeah.
You don't need to do any of these 68 through 72?
No, I get how to do just the graphing by hand stuff.
Okay. Well, the only thing that we might want to look at is domain and range on those, but that's okay. We'll do 73 through 78, and then if we have time, we can go back and talk about that. So we're solving these equations. Good. Those are always the easiest problems to do. You believe that?
Yeah, that actually means...
Yeah, they are, by far. I mean, compared to...
Yeah.
Well, I think they are. Compared to translations and all of that, these are a piece of cake. Solving an algebraic equation should never give you a problem. No matter how complicated I can make one, you can solve them with just a series of steps, even if there's 97 steps. First step here.
You could just subtract 7.
Yeah, the goal is going to be to get that isolated. then we'll go from there. But that's the goal to start with. Well, first thing, subtract 7, so that gives us this. Next.
And divide it by 2.
Now what?
Would you multiply by the reciprocal? So 4/3?
Exponentiate by the reciprocal, not multiply. Multiplying by 4/3 doesn't do anything. But if I exponentiate the entire left side to the 4/3 power, that will reduce that to x. Of course, I have to do the same thing to the right. Notice that I'm going to apply my rules of exponents. When I'm doing a double exponentiation, I'm going to multiply the exponents, so I end up with x to the 1.
Right.
What's 8 to the 4/3 power without a calculator? Which do you do first? The 4 or the 3?
Multiply it by 3.
Take the third root.
Oh, yeah. Yeah.
That's what a fractional exponent means, is that we're going to take the cube root, and then we're going to take that answer and raise it to the 4th power. So that's how you handle fractional exponents. So what's the cube root of 8?
2.
What's 2 to the 4th power?
64?
I think it's 16. If 2 to the 3rd power is 8,
Oh.
then 2 to the 4th power is just twice 8.
Oh, yeah. I was thinking the 4th
Yeah,
power.
the only problem here is figuring out that step right there. But once you do it, let's try another one. Cube roots of 2x plus 1 plus 2 equals 4. First step?
Multiplying, or no, subtracting 2 from both sides.
Second step?
Multiplying both sides by 3?
Again,
Or cube root?
there's a difference between multiplication and exponentiation.
Okay. So cube root of 3.
Not the cube root. Let's rewrite this expression on the left here.
Cube.
I'm going to rewrite it with a fractional exponent just because it's easier to understand that way. These radical signs are never useful, to be honest. Once you get to calculus, you do away with the radical signs because you're always converting everything to a fractional exponent. Now what?
Now you take the exponential 3.
Cube both sides.
Okay.
That's what that means. Is I'm going to cube the entire left side, and therefore I have to cube the right side. Now what does the left side become?
2x plus 1.
Equals
8.
2x equals 7, x equals 3.5. Okay. 75. I'll live with the square root here. Most people are not as uncomfortable with the square root radical. It's only when you get bigger roots that starts messing with people. What's the first step here?
Would you move the x?
What's the goal whenever you have a radical in an equation?
Get rid of the radical?
By doing what? In other words, let me help you. Let me rewrite that as that to the 1/2 power,
Doing the opposite from
which is
Squaring.
Both sides.
Yeah, both sides.
Okay, what's the left side become?
3x plus 13.
What's the right side become?
X squared plus 25.
That's the most common mistake made in algebra, is squaring that, and people only square each term. That's not what you get when you take x plus 5 times x plus 5. What do you get?
Plus 2x
10x.
plus 25. Oh, yeah.
In other words, it's
2
times 5 times x is the middle term.
Yeah.
Okay, now we have a quadratic. Right? Learn to recognize a quadratic when you see it, because the moment you see a quadratic, how are we going to solve it?
Quadratic formula.
Nah, not yet. We might be able to solve it by factoring. But what's the first thing?
Make a equals 0.
Okay, get 0 on one side. So I'm going to subtract that and that from this right side, which leaves x squared plus 7x plus 12 equals 0. Now notice that it factors quite nicely. In other words, don't plunge into the quadratic if you don't have to. How's this factor?
X and x. X plus 4. X plus 4, x plus 3.
Okay. So our answers are what?
Negative 4 and negative 3.
Okay, now, because we started with a radical sign, there is a reasonable chance that one of these answers is not going to work. Let's test both of them. When I plug in minus 4 for x, this becomes 1 equals 1. That works. When I plug in minus 3 for x, becomes 2 equals 2. That works. It's actually one of the rare cases where both solutions work. Most of the time, one of your solutions will not work when you have a radical in an equation. All right. That was 76. Let's look at 77. Good. Notice that when they use a exponent instead of a radical sign, it kind of directs you to the proper solution. You know what I'm saying?
Yeah.
What's first step?
Moving or subtracting 2.
Second step?
Multiplying both sides by
Not
50.
Not multiplying. What's the word? Exponentiating.
Exponentiating.
To what power?
Both sides by 5.
Okay. Does that leave on the left?
2x minus 1.
Equals?
1.
Add 1 to both sides. So x equal 1 is our solution, and that is a solution here. When I let x equal 1, I get 1 to the 1/5 power, which is 1. 1 plus 2 is equal to 3.
Right.
So the secret in all of these is that exponentiation. 78. Well, not the total secret. In other words, one of these ended up being a quadratic, which can be problematic. Now here I'll bet you have one that has a, well, is the rest of this just square root of x minus 5?
Yeah.
Okay, what's the first step here?
Would you exponentiate both sides by 2?
Yeah, I would square both sides. That's another way of saying that. In other words, you only have to use the word exponentiate when it's an odd number. If it's a 2 or a 3, just you're going to square both sides, you're going to cube both sides. If I got to take it to the 4th power, I got to say exponentiate, I guess. So if I square both sides here, I'm left with what's inside the radical. Solve this.
Two x equals -6.
X equal
-3.
Does that solution work?
Yes.
Because you came up with the square root of -8 equals the square root of -8?
Yeah.
Well, that's an interesting one. Because the square root of -8 is certainly equal to the square root of -8, but you can't take the square root of a negative number. So I'm not sure what to say about this. I would say this has no solution. Okay? Even though I'm not sure that's a true statement, because the square root of -8 is equal to the square root of -8. It violates the domain of taking the square root. You can't take square roots of negative numbers, and I realize you can with imaginary numbers, but when you're talking, that's a good question. I'm going to say that for this exercise, there's no solution to 78. But I could certainly see an argument being made to where x equal -3 is a solution. But it could go either way. You know what I'm saying? I mean, the definition of an equation is the thing on the left equals the thing on the right. Well, the square root of -8 is equal to the square root of -8. So I'm not sure that that's incorrect answer, but it does violate the domain. All right. And particularly in the context of looking at these problems right above it, where it says state the domain and range. Well, the domain on 68 is x has to be greater than or equal to 3. Right?
Yeah.
Well, the domain on the range in 78 is x has to be greater than or equal to 5, at least, just based on that. So when we come up with an answer of x equals -3, that's violating the domain, despite the fact that the square root of -8 is equal to the square root of -8, we're violating the domain. So that answer doesn't work. What's the domain on 70 or 69?
Wouldn't the domain, wouldn't they just both be all real numbers?
Very good. What's the range on 69?
All real numbers because it's cube root.
What's the domain on 72?
Would it be?
There's a real easy way to do this. Let me show you the easy way to do it. You don't have to try to outthink it. It's real simple. When I have the square root of x plus 2, and that's my function, and I want the domain, I take whatever is inside the radical sign and make it greater than or equal to 0, because that's what has to be the case. Which means that x has to be greater than or equal to minus 2. Now, don't try to figure that all out from looking at that, because you can get much more complicated stuff here. In other words, what if I gave you this problem? What's the domain of that? Well, the way I'm going to solve that is I'm going to take whatever is inside that radical and make it greater than or equal to 0 and solve that problem. And then whatever I come up with for x is my solution. Now, coming up with a solution for that is not trivial. You have to use line charts and stuff. But still, that's the way you solve it. In other words, no matter how complicated the thing inside the radical sign is, just take it, let it be greater than or equal to 0, and then solve that equation. And that's your domain. In other words, even if it was something like x minus 3 over x plus 5, how would I solve that domain? I would let x minus 3 over x plus 5 has to be greater than or equal to 0, and then I would solve that problem. And that also is not trivial, but can be done easy enough as long as you know the technique. Okay, any last questions, Mitch?
Nope.
Okay, good luck. I'll talk to you next Monday.
All right.
Bye-bye.
Thank you.